Hello everyone, we are the Green Energy Solutions Group. We are working for the climate change. So I am Gurinder from India.
I'm Fawad Ali Khan from Pakistan.
I'm An from Vietnam.
And I'm Alex from the United States.
So first we're going to talk about our problem state. As you can see, this is the CO2 concentration levels that is in our atmosphere. In the past 8,000 years, it has never been higher than it is today. As you can see, normally the highest concentration is only about 300 particles per million, but in 2017 the average was up to 405 particles per million. Another gas that is in our atmosphere, which is really polluting the environment, is methane. As you can see from the very steep exponential growth in this graph, it has never been higher before, with previous levels only at around 700 to 800 particles per billion, but now reaching up to 1,800 particles per billion. This is another issue that we wanted to talk about, which is the melting ice caps. As you can see, this is Greenland's mass variation since 2002. Now, as we know, Greenland is mostly a large ice cap, and you can see that the ice mass measured by NASA's GRACE satellite, it's showing that Greenland's mass has been decreasing steadily over the period of the last 12 years. And finally, this is a a picture showing the temperature anomaly in our atmosphere. As you can see in the northern and southern hemisphere, the temperature anomaly has been rising, and it is up to 2.5 degrees. Now, while some of you may think that a few temperatures isn't going to make a large difference, it's actually not true, and it can really result in a lot of problems for the ecosystems, as they are a very delicate system.
So about the greenhouse gases that are there in the air, about 3/4 of them is carbon dioxide, 16% is methane, 6% is covered by nitrous oxide, and the other two are the rest of the gases. Next slide. So talking about what all contributes to these gases in the air, first is energy production, that contributes to 72% of the greenhouse gases. There are combustion of fuels that contribute to 2.2%, land usage and forestry contributes to 3%, there is waste out there that contributes to 3%, agriculture contributes to 11%, and then industrial processes contribute to 6% of it. So our main focus is energy. So if we come to energy, where all energy is being used? So one, for the production of electricity and heat, that is 31% of the total. Another one is the combustion of fuel, that contributes to 8% of the total. The transportation sector, that contributes to 15%, and then there is manufacturing, construction, and different industries, that contributes to 12%. Next slide. So our preferred state for now is no pollutants from industrial electricity generation and industrial combustion engines, full recovery on the ozone layer, as well as lowering, stabilizing the atmospheric temperature, 100% reliability on renewable resources of energy such as solar, wind, tidal, etc. Restoration of forests to pre-industrial levels. Next slide. So what is our barrier state for now? This is a list of problems, or maybe the factors that are stopping us to achieve our preferred state. One is corruption. Companies and internal governments which support large or more expensive electricity industry. Population, the growing population and the demand of energy and electricity in rural areas. Technological development, slow technological development in green electricity production that could reduce emission of carbon in the air significantly. And another one is subsidies, that is $649 billion spent in fossil fuels. Next slide.
So we've devised a plan which has two phases, which will help us combat the global warming issue that we have.
So this is tidal energy. It's a very promising source of energy for the future. As you can see in the picture, the turbines are placed on the bottom of the ocean, and they can generate vast amounts of energy for like a city or a region. because, as we know, water is 835 times more dense than air. So these turbines, and it won't affect any underwater life because these turbines are moving really slowly, so they won't affect any, they won't cause damage to the sea life.
One of the other very fascinating and promising technologies is that of carbon capture membranes. What these are is it's a semi-permeable substrate with an enzyme biological component placed on top that, when placed above emissions-producing factories or different types of industries, has the ability to collect a huge amount of the carbon and other chemicals coming out that would have a terrible impact on the environment, and allows the healthy bits to pass through. Next slide, please. This is an example of where the carbon capture plants are actually used. You can use these cells of the technology, the biotech, in large factories in their own. So they're cleaning the air on its own. This one, I believe, was built in British Columbia, Canada, under a grant from the Bill and Melinda Gates Foundation. So what this one in itself has the power to do is to do the same amount of air cleaning that 47 million trees do. It's an exceedingly promising technology that can really work to clean out a lot of the atmospheric pollution produced from industry and other sources. Next slide.
So our phase 2 is to cure the problem that we already have, which is global warming.
So the problem for urban cities for now is to tackle with the air pollution that is there. So China has come up with new technology that is large city-scale air filters. These are about 100 meter tall air filters that can clean up the air up to 10 kilometer radius, and these air filters produce about 10 tons of cubic meters of clean air each day.
And so one of our most ambitious and global solutions is our replenishment program. This is a program in which we encourage schools globally as part of phase 1 to grow trees. Now what we want to do with this is to have school districts and students have pupils and staff go outside into nature twice per year, and each time have each person grow up to 10 trees. Now, after crunching some numbers, we figured out that if you implement this program for 12 years, we can grow nearly as much trees as the Amazon rainforest. Currently, the Amazon rainforest has 390 billion trees. After implementing this program for 12 years, you will have up to 310 billion trees, and that's basically having a second lung for our Earth. Now we want to talk about phase 2 and 3 of our replenishment program. Phase 2 is talking about industries and how we want industries to have to regrow what they have destroyed. Now, these would be policies that are put onto industries, and it would be such as if they take down one tree, then they would have to grow 2 in its place. And phase 3 would be our penalty system. Research have actually shown that when inmates spend time in nature, their depression rate lowers. So we want to make a system where inmates can go into nature and grow trees as a part of their job in prison. This will not only help them generate revenue in which they can spend in prison, it will also help them lower the depression rate and spend time in nature. And this is our detailed strategic plan. So the part 1 is scale. Of course, each country is different, and each country has a different problem, so they will have to implement the plan differently depending on the size and the problem of the country. And all the solutions will need to be implemented on a global scale for it to be able to make a real difference, as these are global problems. Part 2 is our cost analysis. We believe that an air purifying tower will cost around $2 million per plant, and these can be implemented according to city, as one tower can have a cleaning radius of up to 10 kilometers wide. So depending on the size of the city, they will implement the number of towers they need. 2 is our smaller size air purifiers. These can be used for parks in smaller spaces. 3 is trees. Now these will be 10 cents a tree, and we believe that it is best for school districts and students to actually fund them themselves, as well this will be a small amount of money for them. From a global perspective, well, this will have to be billions from governments. 4, carbon capture membranes. These are $20 to $60 per ton of carbon produced, and the way we plan to implement this is actually to have the companies pay for the membranes themselves from the amount of carbon they create. So if they create 1 ton of carbon, then they would have to purchase 1 membrane, which will capture a ton of carbon with pollutants in the air. And finally, carbon capture plants. These will be a government-owned plant, and the government can implement them on like however much green air they want to filter out in their cities. So part 3 is the next 6 months. Now over the next 6 months, what we want to do is implement new regulations as well as initiatives for greener energy methods, use laws and regulations to reduce subsidies and redirect investments from fossil fuels into green energy companies, and encourage the testing, invention, and innovation on new green technology. And over the next 5 to 10 years, what we want to do is the implementation of green energy methods and relying on green energy methods instead of turning to fossil fuels. Initiating the Green Leaf Project worldwide, which is our replenishment program, and developing the future of green energy technologies. Thank you.